So this video tutorial is on how to use our rules that we've learned about pedigrees and apply them to any given pedigree to determine the mode of inheritance. So this is the first question that's in your workbooks on page 52. I apologize, we're going to start with the third example, which is on page 53. So don't forget that when we determine the mode of inheritance, we always draw a tree that looks like a choose your own adventure book that starts with one option that splits into two, that splits into two, and so on. So the first thing that we always ask ourselves when given a question is the pedigree given considered to be Y-linked? It's important that you write these rules out because practice makes progress, and the more you write, the more likely you'll remember them on an exam. So the two conditions for a trait to be Y-linked is that only boys are affected in your pedigree. And the second condition of a Y-linked characteristic is that boys always pass on the affected alleles to boys. If we check our pedigree, this rule does not apply. Individual 2-3 is a girl who is affected, therefore this pedigree cannot be Y-linked. Because the pedigree is not Y-linked, then we ask ourselves if the pedigree shows a dominant mode of inheritance or a recessive mode of inheritance. Don't forget the characteristics for a trait to be dominant is that it generally does not skip generations and that an affected individual has at least one affected parent. The conditions for a pedigree to be recessive are that it usually does skip generations, or in other words, two unaffected individuals have an affected child. If we now go back to take a look at our pedigree, we'll notice that this pedigree shows a recessive mode of inheritance because individual 1-1 and 1-2 are unaffected, but they have an affected child. Therefore, this pedigree shows a recessive mode of inheritance. Once we've determined that a pedigree shows a recessive mode of inheritance, we then need to ask ourselves, does this pedigree show that it's X-linked, which means the trait is on the X chromosome, or is it autosomal, that the trait is on a autosome, which is chromosome number 1 through 22. Don't forget, it's always easier to determine if a trait is X-linked compared to autosomal because X-linked traits have very specific characteristics. If a trait is X-linked recessive, don't forget that more boys than girls are usually affected. And the second rule is that an affected mom has to have affected sons as well as an affected dad. If we take a look back at our pedigree, we can see that the first condition is met. In our pedigree, there are 3 affected boys compared to 1 affected girl. Also, if we take a look at individual 3-3, which is the affected girl, she has an affected father, which means that the second criteria is also true. Because we determined that the pedigree is recessive and likely X-linked, our conclusion that we write down in our book is that this pedigree is likely X-linked recessive. On a written question, it's always good to give 2 solid conclusions as to why you think this is true. So one thing that you could write is that it skips generations. Don't forget, it skipped individual 1-1 and 1-2. It's also good to make sure that you write on the pedigree and circle your thoughts as you're going so that your teacher knows exactly what you're talking about, as well to rewrite it as you write your conclusion. The second reason why we know this pedigree is X-linked recessive is also because there's more boys than girls affected. You can always write down other reasons to prove why it's not another mode of inheritance. For example, you can put that it's not Y-linked because there's girls affected. Don't forget our conclusions are not 100% correct because our pedigrees are still really small and it could suddenly show a different pattern if we were to look at future generations. So now that we've determined that this mode of inheritance is X-linked recessive, we can go back in and fill in the genotypes of all individuals affected. Because we determined that this trait is X-linked, we need to make sure we use our sex chromosomes. This individual is a boy, so he will have the XY chromosomes, as well as this individual, individual 3,5, and individual 3,3 is a girl, so she'll have two X chromosomes. Don't forget we have to add the alleles in, and because we said this trait is recessive, every affected individual must have a recessive allele. So individual 2,2 has the recessive allele, as well as 2,5. Individual 3,3 has two recessive alleles, and 2,5 is a boy, so he has one recessive allele on the X chromosome. We're going to go back to example number 1 on the top of page 52 and practice our skills again to determine the mode of inheritance. So what I did is I recopied the steps that we did in the last question, and so you should rewrite these steps out every time, but I wrote them here so that we could spend more time looking at the pedigree. So the first thing we do, just like we did with the other pedigree, is to ask ourselves, does the pedigree show a Y-linked mode of inheritance? Don't forget Y-linked means that only boys are affected and that an affected boy or affected father can only have affected sons. So if we take a look at our pedigree, we can see if this is true. Right away, we can tell that the pedigree is not Y-linked because girl number 2,1 is affected. Plus, if you take a look at individual 3,5 here, he is affected, but he doesn't have an affected father, meaning that the trait cannot come from a Y chromosome. So because our trait is not Y-linked, we then move on to determine whether the pedigree shows a dominant or recessive mode of inheritance. Don't forget that a dominant mode of inheritance usually does not skip generations, and if an individual is affected, they have to have at least one affected parent. If we take a look at our pedigree, this does not seem to be true. For example, girl number 2,1 is affected, but she does not have affected parents. Therefore, by default, this means that the pedigree is showing a recessive mode of inheritance. The pedigree definitely has skipped a generation. It skipped individuals 1,1 and 1,2, but individual 2,1 is affected. Because our pedigree is recessive, we can now move on to determine if it's X-linked recessive or autosomal recessive. Don't forget, if a characteristic is X-linked recessive, which is what we always check first, more boys than girls need to be affected. Also, that an affected mom has an affected father as well as all affected sons. If we go back and take a look at the pedigree, it doesn't show us if more boys are affected. There's one affected boy to one affected girl. So we need to check our second condition. The second condition that says that an affected mom, so the affected girl number 2,1, must have affected sons or an affected father. If we go back up and look, she does not have an affected father. Therefore, the second condition is not true as well. So by default, this pedigree shows a autosomal recessive pattern of inheritance. For our conclusion, we can write down autosomal recessive. And don't forget, when you give two pieces of evidence, you can use evidence for or against it. For example, for this one, the first piece of evidence we can write down is that it skips generations. Don't forget to write down which generations it skipped to make it more clear for your teacher. So in this case, it skipped individual 1,1 and 1,2, but individual 2,1 is affected. And you can also write a second reason, and this time we'll use a reason why it is not another type of inheritance. So it is not X-linked recessive because an affected girl does not have an affected father. Now that we're done determining the mode of inheritance, don't forget that we have to go back and fill out the genotype of all individuals affected. So because we decided that our pedigree is autosomal recessive, we don't need to use the X and the Y chromosome. Autosomal means that it is on chromosomes number 1 through 22, and recessive means the recessive allele. So this girl has a genotype of a, and this male that's affected also has the same genotype of a. So now we'll take a look at our second and last pedigree, which is the second one on page 52, and we'll go through the rules again. So the first place we always start, just like the other two examples, is if the pedigree is Y-linked. Y-linked means that only boys are affected and boys have to pass it on to all their boys. Right away we can see that this is not true because in generation 2 there are many girls who are affected, as well as in generation 3 there's one girl who is also affected. So therefore, this pedigree is not considered Y-linked. So is this pedigree dominant or recessive? The easiest thing is to check is if it skips a generation, so are there two unaffected people who have an affected child, or is it dominant that an affected individual has at least one affected parent? So if we look here, there doesn't seem to be two unaffected individuals, and every affected individual, so if we start at 3-7 and work backwards, every affected individual seems to have an affected parent. So therefore, we can conclude that it's highly likely a dominant trait that we're looking at in our pedigree. Our X-linked dominant conditions are different from our X-linked recessive conditions. So what we first have to do is get rid of the traits that we have written down from previous questions. We're now ready to determine if the pedigree shows an X-linked dominant or an autosomal dominant pattern of inheritance. Don't forget, we always check X-linked first, no matter if it's recessive or dominant. So the two conditions for a trait to be X-linked dominantly inherited is that it first of all must follow the DDD rule, and that is if a trait is sex-linked dominant, if a dad is affected, all the daughters have to be affected. The second condition that it must meet is that affected mothers have to have affected sons. We can now go back up to our pedigree and check our DDD rule, or that affected mothers have an affected son. So let's start with an affected father. So if we take a look at father 1, 2 at the top of our tree, if it's true that this pedigree is X-linked, that means all of his daughters have to have it. If we take a closer look, individual 1, 2 has a daughter who does not have the trait, and a daughter who does have the trait. Since our rule says that if a dad has it, all the daughters have to have it, it's not possible for this pedigree to show an X-linked dominant mode of inheritance. Because our first rule does not apply, we don't need to check the second rule. We can automatically rule out the pedigree to be X-linked, and therefore it is autosomal. Now for our two reasons, we can pick any of the above. This time we can write that it's not Y-linked because girls are affected. And our second argument for why we believe this pedigree is autosomal dominant could be that it does not follow the DDD rule. So to go back and fill out the genotypes of all the individuals affected, don't forget that because we said it's autosomal, we do not use sex chromosomes. And this time, since it's dominant, all affected individuals have to have at least one dominant allele. So you can go through and fill out that dominant allele for all of our shaded in individuals. The second allele you can determine by either looking at parents or children. So individual 1, 2, their second allele is recessive because they're able to have unaffected children. Same reason goes for individual 2, 1. Their second allele is also a recessive allele because they're able to have unaffected children. Individual 3, 2 also has a recessive allele, but this time we can determine that by looking backwards and looking at the dad, which is unaffected, so he must have had two recessive alleles and gave one of those to his daughter. And if we go through, we can use the same reasoning to fill out the rest of the alleles for the individuals affected.